Okay, this is video 1 for chapter 3. So in this chapter, we're going to be looking a lot at algebraic expressions and what those are. This goes with 3.1. You can see the pages there. And the target, write this down on your note sheet, is to identify terms and like terms and use different properties to simplify algebraic expressions. So we're going to start with some vocab. This section is kind of an introduction to a lot of concepts that we're going to use for the whole chapter. So a lot of important vocabulary here. The first one is algebraic expression. What is an algebraic expression? Well, algebraic expressions are numbers, letters, and symbols. Numbers, letters, and symbols. So here's an example. I have 2x squared plus 3y minus z. That's an example of an algebraic expression. So I have some variables, I have some numbers, some plus and minus, positive and negative signs, okay? But it does not have an equal sign. So it's not an equation. It doesn't say it equals anything, just the numbers, letters, and symbols. Remember to pause if you need to while we're doing this if I'm going too fast, okay? Second vocab, terms. So an algebraic expression can be broken down into terms. The terms are each piece or each part of the algebraic expression, okay? They're the different pieces separated by either the plus or the minus sign, okay? And we're going to talk about how those plus and minus signs are also positive and negative signs. But in between all of those plus and minus signs are your different terms, okay? So if I go back to my example up here, this is a term, 2x squared. This is a term, 3y, and then this is a term, actually negative z, right? Those positives and negatives tell us, or the plus and minus signs tell us positives and negatives. So this last one is a negative z. So my example here had 3 terms, okay? So like terms. Well, once we figure out what the different terms are, some of them are like terms. Those are like matching parts, terms that have the same variable to the same exponent, okay? So I'll give you some examples. 2x squared and negative 5x squared, right? So those are both the same variable to the same exponent, same variable, same exponent. Those would be like terms with each other if they were in the same problem. Or another example, 7q and 5q, right? Those both have the same variable, same power. Those are like terms. I'll give you an example of things that are not like terms. 4y and negative 3y squared. Those are not like terms because this exponent, the exponents don't match. They have the same variable, but not the same exponent. So you got to check both of those things when you're looking for like terms. And we'll do lots of examples with these in this section, but just get that vocab definition down. Okay, so vocab 4 is to identify. So that's a verb. When the directions say to identify, they want you to find and list out whatever they're asking for. So a lot of the questions we see will say like identify the terms or identify the like terms. Those are examples of questions you'll see, and that means find them and tell me what they are. Okay, the next vocab is coefficient. It's kind of a big word, but that just means the number multiplied by a variable. Okay, so if I'm looking at a term like 5x, the number that gets multiplied by that variable, by the x, is 5. So the coefficient is 5. Or negative 7p. Well, the number that's being multiplied by that p, or in front of that p, is negative 7. So negative 7 would be the coefficient. Okay, remember when we look at terms like this, in this whole term, this means 5 times x. And in this term, it means negative 7 times p. We don't write that multiplication sign in there anymore, but we know that the number and the variable right next to each other mean we're multiplying. Okay, vocab number 6 is constant. A constant in this case, when we're talking about algebraic expressions, is just a number by itself, no variable. So a constant, 2, or 1.7, or negative 3. Any just plain number without a variable next to it is a constant. Okay, pause if you need to catch up. I'm on to number 7. This is combine like terms. Again, this is a verb. This is what the directions might say. Combine the like terms, okay? And here's our definition. It means find and put all the like terms together, okay, as one term. So we'll do lots of examples of this. Kind of this whole chapter revolves around being able to combine like terms. So find the terms that are like terms. That's another vocab that we already talked about. Find the like terms and then put them together, okay? So we'll do plenty of these examples, but if you write that definition down. And then the last one, simplest form. So simplest form means write out your algebraic expression with no parentheses and no more like terms. Okay, so that means we're going to combine all the like terms that we find and write them kind of in a condensed form, so we don't have kind of repeats of things. Okay, so simplest forms means no more parentheses, no more like terms. Okay, so I know the vocab doesn't make a ton of sense until we do some examples, which we're going to do right now, but at least you have it all there to look back on. Okay, all right, so here we go. Examples of simplifying. These are on your paper. Let's talk about them. Here's my first example. If I said something like this, okay, you have a smiley face plus 3 smiley faces plus 5 more smiley faces, and then you take 4 of the smiley faces away. Maybe they're stickers or something. How many smiley faces do you have? Okay, this is an example of combining like terms. In this case, my like terms are the smiley faces. So they all have smiley faces. I have 1, 2, 3, 4 terms. They're all like terms because they all have the smiley face, so they match. Okay, so if I asked you to do this, you'd say, okay, well, this is just 1 smiley face plus 3 smiley faces plus 5 more smiley faces. Let's see, that gives me 9. And then if I take 4 of those smiley faces away, I end up with 5 smiley faces. Okay, so that's what I mean when I say combine like terms. Take all those 4 terms and just simplify it down into 1 when you put the like terms together. Okay, so you can see here that I could replace those smiley faces with a variable. A plus 3a plus 5a minus 4a. Again, they're like terms because they're all the same variable with the same exponent, right? No exponent, or just a 1 that we don't write, exponent. And I would put it together the same way and get 5a. Okay, so you try this one. 4n minus 6n minus 10n plus 2n. Okay, now I'm going to teach you a trick. I want you to underline the terms. I've got 4n. Now this negative stays glued to the 6n, so that's negative 6n, and then negative 10n, and then 2n. Okay, so again, I have 4 terms. They all match. They all have the same variable, n to the same exponent. And now I put them together. So I can just work left to right. 4n minus 6n, that would give me negative 2n, minus 10 more n. Okay, if I keep going, that would give me negative 12n. And then plus 2n. Well, negative 12 plus 2 is negative 10n. So combining these like terms, since they're all like terms, I can work it down just to negative 10n. Okay, here's another example. So again, I have some smiley faces, but now I also have some stars. Well, the smiley faces and the stars don't match. They're not like terms. But I can take these smiley faces and these smiley faces and put those together. And then I can take these stars and put those together and combine what are like terms and still simplify this expression. Okay, so in this one, if I look at the smiley faces, negative 2 smiley faces and 7 smiley faces would give you 5 smiley faces. And then if I look at my stars, 6 stars minus, always if there's no number there, that's a 1. So minus 1 star, well, 6 minus 1 gives me 5 stars. So if I just look at my like terms and combine what I can, I get 5 smiley faces and 5 stars. Okay. Here, let's look if I change those to variables, right? If I say the smiley faces are B's and the stars are N's, right? You can tell, okay, these N's would combine with those N's, and these B's would combine with these B's, and I could put them together, and I would have a total of, back to blue, I'd have a total of 5 B's, and then a total of 5 N's. And if it's positive 5 N's, I put a plus sign there saying it's positive 5 B's and positive 5 N's. Okay? So here's one more for you to do. Here's an example. Look for your like terms, and here's where I like to color code. Okay? I've got X's and more X's. Remember, this negative stays glued, so that's a negative 8x. And then I have 2y and 5y. Okay, I'll put my like terms together. So let's do the x's first. When I look at just the x's, 5 and negative 8 make negative 3x. And then I'm still color coding. I'll put my y's together. 2 and 5 make 7y. And if it's positive, put a plus sign there. Okay? So when I combine these like terms, I have negative 3x plus 7y. Okay, so here's the big ideas, right? Write these down. Color code the like terms. Color code the like terms. And then combine those like terms. Combine the things that are the same so that you get it simplified down. Okay? So let's do a couple more examples at the bottom of your paper. Let me erase this. Here we go. So looking at this first one, I see B's and C's and a plain number, a constant by itself. Okay? So I'm going to find my like terms and color code them. 3b goes with negative 2b. And notice that I kept that negative with that term. And then the c's, I have negative 9c. Again, that negative stays with the 9. And 4c. Those go together. And then I just have that negative 8 by itself. It's the only constant there. Okay? So I found my like terms. I color coded them. Now I'm going to put them together. So let's do the B's first. 3 B's minus 2 B's. Well, 3 minus 2 leaves me with 1 B. So I can just write B. And then negative 9C and 4C. Well, negative 9 and positive 4 makes negative 5C. Again, it's negative, so I put that minus in there. And then the 8, the negative 8, doesn't have anything to combine with, so I just bring it down. Okay? All right, so the next one. Now I have all V's, but some of them are squared and some are not. Let's find our like terms. Plain V, 6V, negative 3V. So those are 3 terms that go together, like terms. And then color code, I have 4v squared and negative v squared. Okay? Remember, no number means that's an invisible 1. All right, let's put the v's together. So I'll go back to blue. 1v plus 6v makes 7. Minus 3 leaves me with 4 v's. And then I'll go back to red for my v squared. 4 minus 1 is 3v squared. And if it's positive, put a plus sign. Okay? All right. You do this last one. Looks like I have q's, r's, and a q squared there. So color code, find your like terms, and simplify. Okay, I color coded. I got my q's. Notice that these are both negative, so I ended up with negative 10q. Then I put my r's together. Remember, no number means it's an invisible 1, so 1 and 5 make 6 r's. And then I just brought my q squared down because there's nothing to combine with that. Okay, now I know this is simplified because I don't have any more like terms, no parentheses. That's my answer. So we're going to stop there. This is kind of the basics of the first section, and we'll go on in the next video to do kind of more examples together.